So this might just be the best ice chest air conditioner ever. Hi everybody, I'm Alex and welcome back to the Renaissance Builder. Now yes, it is getting cold outside and the season for building air conditioners is probably well past us for this year at least. But if you click on this link, then you can check out the last video where we put this thing to the test and the fan took a dump on us. Now I never got to straighten that out and I promised you guys I would look for the best fans to work on this system. So the first point of this video is to finalize our water chiller based homemade air conditioner, which I have put together the best components that I could find to build the water chiller based air conditioner, homemade air conditioner. Best components. The second point of this is I also want to try turning what would be an air conditioner into a space heater. So we are getting into the season where we need heat in the small areas that we like to reside in. And I say small areas because you really can't expect a whole lot out of these homemade units. I have an idea of using some submersion heaters, heating elements, to actually turn what was an air conditioner into a heater. So we're going to give that a whack eventually, but for now, we are going to set this homemade air conditioner or water chiller based homemade air conditioner up the best I can possibly arrange it. For starters, the coil that we already have on here is actually a transmission cooler from like you can get from Pep Boys or Napa or whatever auto parts store you go to. This didn't work out all that well. The components that we are going to replace this with. For starters, the fans. We have here three 120 millimeter Noctua case fans. Now these are not the RGB fancy fans. You don't need that stuff. In fact, you couldn't use that stuff even if you wanted to. But these are arguably the best computer case fans on the market. I say arguably because I'm really not that knowledgeable with the computer stuff, but reading reviews and looking up informations and everything, this is pretty much the best you can get when it comes to airflow in a computer case. Now, you might ask, why does the computer case matter so much? Well, the computer case matters because computers run on 12 volts. So do cars run on 12 volts. So these are essentially 12 volt fans. So by using computer case fans, not only are they quiet, they move a lot of air, but we can power them with a cigarette lighter. So that's why the computer case fans. And so that takes care of the fans. What we have here is a new radiator. Now this is what's called a 360 millimeter computer case radiator. Well, case, I mean it's a computer liquid cooled radiator. This one's from AlphaCool, and honestly I just happened to get it when I was looking for a deal on some other stuff I had gotten, so the dude like tossed it in for free and I was like, well shoot, I'll take it. But it is pretty straightforward. It's a copper tubed finned radiator. It goes in one side and out the other. Nothing terribly fancy about it. I will say this, and I feel like I have to clarify this. This is not by any means the cheapest solution to do this. But I told you I was going to give you the best setup I can give you, not the cheapest. So, these radiators are kind of expensive. And these fans, relatively speaking, are kind of expensive as well. If I'm not mistaken, they cost like $25 a piece. So there's a little bit of money in that. But I'm predicting that it will actually work for us a lot better, be quieter. Well, I don't know, this was pretty quiet. But it'll be quiet, move a decent amount of air, and definitely get the job done of cooling a space down with the ice that you put in the cooler. And hopefully warming a space up. Don't forget that. So, the process that we're going to do here is we're going to tear the old radiator and fan off, install the new radiator, which shouldn't be too difficult, with the fans on it. So let's get started with that. So now that we have everything torn off that we are ditching in this case, the fan's junk, the radiator I might use in something else, so we'll save that. But now that we have all that off, we can go ahead and start installing the new stuff, which is pretty much everything in the reverse order. We got the radiator mounted and the hoses hooked up. Unfortunately, I had to pull the return hose up a little more because I needed the extra room. Computer case fans mount to these radiators uniquely. It's really not that special as much as you just gotta, if you're doing this yourself, you just have to understand what you're actually doing. So there are pre-threaded and tapped holes. Threaded and tapped, that was a little extra. So there are pre-tapped holes in the fan, in the radiator fan. Now, as I mentioned, this is a 360 millimeter radiator, which takes 320 millimeter fans. Yeah, it's pretty easy to understand. So these holes in the radiator that already exist in the radiator line up perfectly with computer case fan holes, mounting holes in there. So all you need are a few screws. Now, normally your radiator will actually come with the screws necessary to mount the fans to it. In my case, it didn't. It was free. I'm good with that. So I had to go out and buy the screws necessary to mount the fans up here. But normally, it's not completely necessary. So what we're going to do is go ahead and mount these here fans. And it'll just be 1, 2, 3. Mount the fans with the screws. And then we can move on to the wiring. I should mention, it is critical that you make sure when you put your system together, anytime you're messing with these here radiators, that your screw does not protrude so far through the mounting hole that it ends up putting a hole in your actual radiator. So there's like a couple millimeters worth of depth between the mounting plate and the actual radiator. You want to make sure you don't put that screw into the radiator itself, or you will have bricked your radiator, per se. Ooh, this is a job for an iFixit kit. should be noted, you should probably pay attention to the arrows on the fan as to which way the air is going to blow. In my case, I want the air to blow out the front, so I need to flip this around. And in case I was mumbling too much there are arrows on these fans. In this case, it's on the bottom. There's arrows that tell you the direction of airflow. So that when you power these things up, you know, if you want the air to move in a specific direction, if you care about where it goes, then you got to pay attention to those arrows. There you have it. Now we're actually mounted in here. So we have our radiator mounted, we have the water lines plumbed into the radiator, and then we have our fans mounted here. So I have my fans in the orientation so that the air blows towards the front of the cooler. I don't know, that's just the way I wanted it. Obviously you can blow towards the back however you want to do. Now, since these fans are a bit more expensive, instead of hacking in to the wires and cutting things up and making it so it's a pain in the rear to reuse them or anything, I went ahead and bought the jumper kit. It's just a couple extra more dollars, but it'll make this go further. So this gives two splitters that use the same ends, the pin ends here, so that I don't have to actually cut any of the harnesses for the fan itself. And in fact, I only have to modify one of these harnesses, if that even, in order to make this work. So wiring, in that regards, is pretty simple. Okay, so at this point, I have everything wired up. All the fans are mounted, the radiator's mounted. I even put some water in there to make sure that the pump was pumping correctly and all the rest of the good stuff that goes with it. So we're ready to test this thing out. So I'm going to take out my temperature sensing probe here because my other smart probe, well, I'm not sure where it is right now. But there's pretty much nothing more trustworthy than a K-type sensor probe. So that's what we're going to use. Ooh, 72 degrees in here. All right. So we're going to add some ice to this sucker and turn her on and see how she performs. Now I'm not putting the, 3 bags of ice in that I did last time, but 32 degrees is 32 degrees. So we're going to run this and see how it works. Now, we're looking at about 70 degrees in here. It feels warmer. I think it's sticky. But anyhow, what I'm going to do is turn her on. There you go. You can hear the little clunking around in there of the ice. I have to admit, these fans are slightly noisier than the one large fan that we were using before. However, these are pulse width modulated, so if you really wanted to, you could take a couple resistors and add a voltage signal to the PWM pin, and that would actually give you speed adjustment, so you could turn it down if you wanted to, but it's not really that noisy. I mean, my microphone's right here, so you can hear it, but it's there, so, you know, have to admit that. All right, cool. So if I open this up, yeah, we can see the water flowing nicely, and let's see what our performance is like. It blows a nice amount of air, not like super forceful, but a nice volume of air. Like right now I'm at 58 degrees. 58 degrees is nice feeling air. If I move it around to back to get the incoming air, all right, so we're stable at 68 degrees incoming, which is a lot colder than I thought it'd be in here. I'm sweating. I think it's warm. Like if I hold this thing up here, 68, all right, whatever, we'll go with it, to 58. So we're actually only getting a 10-degree split, which isn't as high as I thought it would be. However, we're moving more volume of air. If I did, like I said, and put a variable resistor in here, then I can actually turn the speed down and make it colder. But at this point, we're more interested in cooling the place off. So maybe what I should do is just see if we drop temperature. Yeah, so I'm back down to 58 degrees. So we got a 10-degree delta T across this coil. Now, 10-degree delta T isn't phenomenal, but considering all we're doing is cooling a space off with ice, like we're not using mechanical energy to do so, I think that's incredibly good. And like I said, if I wanted to, I could turn the speed down and drop the temperature even further. The other thing that we're doing that I'm not measuring right now is we're actually dropping humidity as well. The coil is cold enough, and I can see it condensing already on the metals. The coil is cold enough to, the metal is below dew point, so it's condensing. So the moisture from the air that's hitting that coil is condensing and dropping off of the coil. So the air that's coming out here is actually drier than the air going in, which is a good thing. Yeah, so 10-degree delta T. Here's the low down and dirty of it. This is easily my favorite or my preferred ice chest air conditioner, or ice chest based air conditioner. For one, let's say you have a van, right? And you want to have your cooling unit either blowing on you or in a different location than your ice reservoir. The only thing connecting you is a wire and two hoses. So if you make the hoses longer and you make the wire longer, then you can put the coil somewhere else, and you can have your ice chest in another location, so that maybe your ice chest is in the back of the van, right? And you run a coil over to, say, the middle of the van where maybe you're working on your computer, doing editing videos, and you just want that nice cold air blowing on you. Then, voila. Put the chest in the back of the van, run your tubing over, put the coil right where you want it, run a wire, and ta-da, you're done. Now you just made a split system. So this is versatile AF. And it's easily my favorite style because not only does it work well, it also dries the air. None of the other units dry the air. Like your units that have the air blowing across the ice, they're actually making the air wetter, which in very dry climates is a good thing. However, this is universally better, right? If we dry the air. The downside of it is you are going to use a great deal of ice to maintain, but there's a trick. Now, I don't recommend adding salt to your water because there's a pump in there, and the salt is going to add a very corrosive nature to the water, so that all the metals, and especially the pump, is going to have a much shorter lifespan. But what you can do is add alcohol to the mixture. By adding alcohol, even rubbing alcohol, you do the same thing as if you add salt. So you drop the temperature at which the water freezes, which means I can now make that water colder, less than 32 degrees. So now maybe I can make the water 20 degrees before it actually freezes, which means it's significantly more useful. The greater delta T we have in the water, the more useful this thing works, the better it works. The other trick you can do is ice packs or frozen bottles. And I'm even going to try and experiment with small jars of dry ice. Not necessarily blowing the air across the dry ice, but something that the dry ice can be in that is simply extremely cold so that it cools the water off. But use a bottle, like a bunch of frozen water bottles, right? Stick them in the freezer and get them down to 0 degrees. And at 0 degrees, you can put that in there, and that will all help. That'll work better than just dumping ice in to bring it down. All this is kind of balanced on the idea of having those resources available to you. You may not always have those resources available to you. At which point, say you're in the middle of the desert or somewhere in the sticks where you don't have access to ice, you don't have access to a freezer, but maybe you have access to just running water that is colder than, the air around you. If you simply just drain and refill the water in here, then you can get air conditioning that way as well. Either way, the whole point is that this is an extremely versatile system. So, being so versatile, being so adaptable with being able to split the air handler in your reservoir, and just the simple nature of the whole thing and the fact that it dries the air as well as cools, tells me that this is my favorite style ice chest based air conditioner. With that being said, thank you very much for watching this video. Make sure you hit a thumbs up on there if you liked it. Make sure you're subscribed. Hit that subscribe button right down there. It's down there. Hit it. It's the little red thing. It says subscribe. Punch it. And hit that bell icon so that you're notified in future videos. Like I said, we're going to turn our air conditioner into a heater, see if that works, and future videos beyond that. We're going to have some fun stuff, lots of great things planned, so I look forward to seeing you guys in future videos. Till then, have a good night.
Bye-bye.